Hi everybody, this is Mr. Folly, and whoops, I almost wrote my name right. And we are looking at podcast 9.4. We're going to do delta H of a reaction, which is called calorimetry. We're going to do heat stoich, and we're going to do LOL heat and chemical energy. So let's do some more stoich with that. All right, so heat is also a reactant or a product. So if I have C plus O2 yields CO2, simple chemical reaction, many times you'll see delta H equals negative 393.5 or any number. This could be any number. This particular number is 393.5, but that's not true for all of them. This means the reactants, these guys right here, lose 393.5 kilojoules per mole of energy when the reaction occurs. So what that means, if they lose it, that means this reaction releases heat. Okay. Another way to write this exact same thing is like this. So notice it doesn't mention delta H, which for us is it's really enthalpy, but it tells you the heat energy, the change in heat. Here, this makes carbon dioxide and it makes heat or releases heat. These two mean exactly the same thing. So if I give you a matching question, what happens here? If this is negative, heat goes on the right. Okay. We can use stoichiometry ice diagrams, determine the amount of heat needed or released. So this way amount means we're actually going to get a number on it. How many kilojoules of energy will be released when 4.72 grams of carbon react with excess oxygen gas to produce carbon dioxide? So do you see how I have 4.72 grams of carbon? Now I want to convert this into heat. So I'm going to take this and throw it into the equation. So notice this is negative, so it's going to go on the right hand side, plus 393.5 kilojoules. Oh, darn it. Oh, darn it again. So what I'm going to do first is I'm going to convert 4.72 grams of carbon into moles. So we've done this a ton, a ton enough that I just did it wrong. So 4.72 times 1 divided by 12.01. Let me reach for my calculator as you reach for yours. And I get 4.72 divided by 12.01 is 0.0393 moles of carbon. So that means now I'm going to do an ice diagram, and I have 0.0393, and I'm trying to get this heat right here. Okay, so ice diagram, 0.0393, and oops. And the change here, this is going to lose 0.0393. And in the end, I'm going to have 0. Now over here, I start with 0 heat being released because the reaction hasn't happened yet. Now here's where it gets crazy. I have my coefficient here is 393.5. Oh, stop that. 393.5 over 1 times 0.0393. See how that works? My coefficient in this case is the weird number 393.5. So I'm going to take 393.5 times 0.0393. 393.5 times that, and I'm going to get 154.6 kilojoules. That's my answer. Okay. So what we learned here is treat kilojoules like, it's not the same thing, moles, which means use your coefficients. All right. Let's go to the next one. If 256 kilojoules of energy were released in such a reaction, how many grams of ammonia gas were reacted? Now notice here I've got negative 1170. So what I'm going to do here is just put 1170 on the right. Okay? So I'm putting 1170 here on the right because this is negative. That's why it goes on the right. Now here, I'm going to rewrite this reaction. 4NH3. Get back here. 4NH3 plus 5O2 yield 4NO plus 6H2O plus 1170 kilojoules. Now what happens here is we know we're going to do an ice diagram just like before. treating kilojoules just like moles. So I'm going to have 200, get back here. I'm going to have 256 kilojoules of energy released. That's the product, so I'm going to put it down here. 250 kilojoules released. We know this is going to be 0, right? How many grams of ammonia? Okay, this is ammonia over here. So what I notice here is, get back here, this is going to have to be plus 256. Now here, this is going to start with a certain number. My change number here is going to be, remember, look at my coefficients, a ratio of my coefficients. 4 over 1170. Isn't that crazy? 4 over 1170 times 256. Now why times 256? That's the change amount. Remember, the change is where all that magic happens. So I'm going to take 256 times 4. Oops. 256 times 4 divided by 1170. And that's going to give me, and this answer right here is 0.875 moles. Okay, so that would be the number of moles that I start with. Get back here. Okay, now the question says how many grams is that? So now I'm going to take I'm going to go back to that slide. Take 0.875 moles of NH3 and times dividing bar, do 1 mole of NH3 and go to grams, which is 17.04. Go to the periodic table of NH3. So 0.875 times 17.04 is 14.91 grams. So do you see, again, the weird part is kilojoules are just like moles. Reactions are endothermic or exothermic. If they're, oh man, look at what I did. Hope you didn't write that down. If you did, you wrote it down twice. Endothermic, shame, shame, shame on me. If it's endothermic, delta H isn't negative. These are all opposites. Delta H is positive. And heat isn't on the right, you big silly. Heat is on the left. Oh, get back here. Left. The other thing about endothermic is it feels cold. Exothermic, delta H is negative. Ba-bing. Heat is on the right. Ba-bing. And it feels hot. And there you go. There's the two little definitions we need to know. Now we need to be able to do LOLs for exothermic diagrams, okay? Uh-oh. So what we have here is, all we're going to deal with here is not the chemical energy. We're just going to deal with the thermal. Oh no, we'll leave that in there. Where's my eraser? Here's my eraser. Okay, so what's going to happen is, if you remember doing these guys, they're all going to have to equal out. Okay, so if this is negative 1170, what that means is that heat is going to flow out of it. Okay, so heat is coming out. Negative means heat out. So if heat is coming out, that means my thermal energy is going to be lost. So if my thermal energy is going to be lost, thermal energy is going to be lost, get back here twice. That's supposed to be back, not forward. Thermal energy is going to be lost. Thermal energy is going to be lost. That means that my chemical energy will have to be gained. Does that make sense? We're not doing the way later thing. Okay? So some of that energy is going to be converted into chemical energy. That's it. So LOL is for exothermic. If it's exothermic, ETH goes down and ECH goes up. This is endothermic. LOL for endo is the opposite. Endothermic means heat's going into it. So heat is going into it in endothermic reactions. If heat's going into it, my thermal energy is going to go up. Oh! And where did that energy come from? My chemical energy will go down. Okay? So ETH goes up, ECH goes down. And they will equal each other. Uh-oh, that says the wrong review. So we will say toodles there. Toodles.